Now, if we go to the part B of question 3, we remember that person was on top of a cliff and they threw a rock up at 8 meters per second. It went up and fell down below the cliff. Height of the cliff was 78.48 meters tall. And now they're asking, how long does it take for that rock to hit the ground? So to be able to do this, we actually have to break this problem up into 2 parts. We're going to break it up into the time it takes to get to its maximum height. And then we're going to look at the time it takes for it to reach the ground from that maximum height. So let's start with this upward part. We're going to write our givens for that first part of the trip as the velocity is positive. So if we write our givens, the initial equals, well, at the start of this part of the trip, the velocity initial is positive 8 meters per second. We also know at the end of that trip, we know the final velocity. V final equals 0 meters per second. So that's an important thing to realize. At the top of any projectile or object that goes up and then reverses direction and comes down, that top maximum is always going to have a velocity of 0 meters per second. We'll actually use that in the second part of the trip as well. So we also know acceleration is negative 9.81 meters per second squared. And we're trying to find our time. Okay, so we have all our givens and our unknowns. If we look at our reference table, we see that we have initial and final, acceleration, and time. So we know that V final equals V initial plus AT. We have a final of 0 meters per second. Don't forget, we substitute in with units even when there's a 0 value. The initial is 8 meters per second. Then we're going to add our acceleration, meters per second squared, and we're looking for our time. 0 equals 8 minus 9.81 t. We can move the 8. We get a negative 8 equals negative 9.81 t, and we can divide both sides. 9.81 negative divided by a negative, we're going to get a positive value. If I take out my calculator, I have 8 divided by 9.81. We get 0.82 seconds equals t. So now we figured out the time it takes for our upward portion of the rock falling through the air. So just under a second. Now we have to do that same calculation, but for our downward portion of the trip. So I'm going to change colors to match. And we know now our trip starts up here. This is the initial, and the final is all the way at the bottom. So V initial equals 0 meters per second. That's that thing that you need to know about all objects that go up and come back down. At the top, they have no velocity in the y direction. Now, we actually have V final from above. So V final equals 40.05 meters per second. We know our acceleration for all objects falling on Earth, meters per second squared, and we're looking for our time. So we can use that same formula because we have all the same givens and and unknowns, AT, and our V final, 40.05 meters per second equals 0 meters per second plus negative 9.81 meters per second squared times time. So 40.05 equals negative 9.81 t. We can divide by 9.81. Negative 9.81. And I stopped myself because I'm seeing here that I'm going to get a negative time, which seems weird. I shouldn't get a negative time. It's not before our starting point in time. It wouldn't be before here. It doesn't reach the ground. It's after this point it reaches the ground. So I must have made some mistake somewhere. See if you can look at my work and see where that mistake is. Okay, so our V final is actually negative 40 meters per second. Why is it negative? It's actually negative because it's moving in the downward direction. Where on our green path, our initial was positive because it was moving in the up direction. So that final velocity, if I drew it in my diagram, that final velocity down here that's where the rock is. It's downward, and it's a larger arrow than our 8 meters per second. It would be a negative 40.05 meters per second. Okay, so why didn't I have that in here? Well, when I did my square root, I have to realize all square roots can be plus or minus, and it's our job to know what's the direction. And in this case, the direction was down. So be careful with that. Remember that velocity always has a direction. So now if I go back to my problem and I fix my velocity as a downward velocity, negative 40, we get a positive time. I punch that into my calculator. I have 40.05 divided by 9.81, and I get 4.08 seconds. And that's only for the downward portion of our trip. So we haven't actually answered the question yet because it's asking how long does it take to reach the ground. And it hasn't reached the ground unless you put both of these together. So we're going to take our upward trip and our downward trip and add them, and we get 4 seconds and 9/10 of a second. So 4.9 seconds is our total time for the whole trip, including the up and the down.